In the previous video, I showed you when you do regression, you need to watch out outliers and influential observations. So like that, there are many other little things you need to watch out when you do regression. So in this video, I'm going to kind of show some of those things. Okay, so these are some of the questions you need to watch out basically. The first one, the correlation and regression lines describe only a linear relationship. Pretty much that's what we did look at in this class so far. Okay, so in other words, if the data has this kind of linear relationship, sort of like this kind of trend that will work. But suppose the data might have this kind of trend, this type of trend. So in that case, this may not work out. So you might have to look into something like that, like a quadratic equation, cx square type thing, or the other way, the data may have like this kind of shape, sort of like that, go up and then go stay flat. So there are different situations. Okay, so anyway, that's one of them. So in general, when you look at the scatter plot, you can kind of look at it, what is going on. But later, like in a couple of chapters down the road, you will see that there are other techniques actually, if we will get into that. Certainly in this class, we are not going to get into that. Okay, so the second one, correlation and least square regression lines are not resistant. Always plot your data and look for observations that may be influential. So that you already have seen that, how to watch out for influential observations or the outliers. Okay, the third one, so beware extrapolations. So this is a good example actually. So in this example, what you're looking at is that you're trying to suppose you're trying to analyze the height of little kids from age 3 to 8. So the height with their age. So in other words, you're looking into like the age here and the height over there. But you're looking into the kids with from age 3 to 8. So if you look at it, so there's most probably it will have a linear trend within that range. Okay, so what happened is that, so if you do that, use a regression line, and suppose you're going to use that result to predict the height of a person when that kid grow to 25 years or something like that. Okay, so what will happen is that if you use that linear trend, you're going to get about the height is going to be 8, 9, 10, something like that. But the reality, so the kids, when they grow, that is not a linear. It will go up like that. So after a certain time, that will slow down the rate of growth. Okay, so which means basically that you cannot, you don't want to extrapolate the height beyond that range you're looking at. In this case, if you collect the data within that, you don't want to go beyond that in general. Most probably what will happen is that if you go beyond that, you are more likely you might end up making errors. Okay, so that's the question is about. Okay, so it's like that example we did before. In other words, you remember that we were looking at an example like that. See, we collect the data, the x range. So from here, see the x range from here to here. So if you want to predict something within that, once you get the regression line, within that is okay. But you don't want to go beyond here or over there. Okay, so that's what it's about. So the next warning is that beware of these lurking variables. So a lurking variable is a variable that is not among the explanatory or response variable in a study that may influence the interpretation of the relationship among those variables. Okay, in other words, there's some kind of another variable that might influence basically the relationship between the response variable, which is y, and the x, whatever the two variables you are looking at. Okay, so the y and the x. So there might be some other hidden variable basically. So those kind of variables are known as lurking variables. So I'm going to show you several examples. Say for example, this is a good example. The aid during this for instance, the worldwide AIDS epidemic and the internet use have been exploded over the past 2 decades. Okay, and thus you could expect to find a positive association between both variables. So both during the past 2 decades, basically both of them went they got very high, so therefore there's a positive correlation. However, you can see that the association is purely coincidental and meaningless basically. Pretty much that has something to do with that timeline. Both went up. One has nothing to do with the other, even though there's a positive correlation. Okay, so you need to watch out that kind of lurking variable, especially if you're going to interpret. If you're going to say that one is going to control the other, no, there really is not the case in this case. Okay, one has nothing to do with that, even though there is a positive correlation. Okay, so this is another example. So in this example, actually this is a good example too. So the question is this: which students scored 51 points higher in verbal skills and 39 points higher in math? So the answer, whatever they study, they will say in that answer, students who had experience in math, who had experience in music. So whatever that they study the music as well as the scores. The response variable is that there are scores in these things. Okay, so somehow they see that there's a connection, positive connection. Okay, so however we could probably just as well answer that question: students who played soccer. Okay, so why that is the case? Basically what happened is that the kids who play soccer, so maybe their parents are more basically their family backgrounds is much better, socio-economic background, they don't know what to do with those kids. So the other kids who doesn't do those kind of things, they're poor and then they don't know what to do. Okay, things like that. So in other words, so actually this kind of study, so in these people, okay, they kind of used to advertise it, so that the advertisement basically use that one to attract people into music. Okay, so the bottom line is that the family background is a lurking variable that explain, at least in part, it doesn't say that may have some impact, okay, may have some impact, but at least in part why the test scores are related to experience with music. Okay, so that's what. Okay, so that you can see that where that variable is coming into the picture. Okay, so in the next example, another good one. So in this, so high blood pressure and stiffness are related factors for cardiovascular disease. Okay, so in this study, basically they are looking at sympathetic nerve activity as well as the stiffness indicator to study the basically cardiovascular disease. So this data, they are collected for male and female both. So this is that combined data for male as well as female. So if you look at that, certainly you do not see any pattern within the data. There's no any correlation. Okay, so in other words, if you figure out the R value we were looking at before for this data, so this is the R value, so it's nearly 0. There's no pattern, any linear pattern anyway. So okay, R equal near 0 minus 0.17. Okay, But the thing is that if you separate that data, male and the female separately, if you look at it that, so this is for the male, so there's a positive trend in this data. And for female, there's a trend, negative trend. So positive trend, negative trend. For this data alone, this R value, so it's going to be positive, so it's 0.53. For this female, that is going to be minus 0.58. So what happened is that, so the gender is going to play a very big role for these two variables, the connection within these two variables. So if you ignore the gender, you see nothing actually, okay? So that's what happened. In other words, in really, if you want to study this and that, gender has to be a part of that, okay? So basically the gender is a lurking variable that drastically affect the relationship between the two quantitative variables studied in this case, okay, those two variables. So in really, see, right now we are not looking at how to incorporate the third variable into the picture. That's something, I don't think that in this class you are going to see it, okay? But you can incorporate that kind of thing as a third variable into the picture, okay? So it's later on, okay, not in this class, okay? So anyway, you can see that you need to watch out these kind of things when you do regression analysis, okay? All right, so the next one is that association does not imply causation, okay? A strong association between two variables is not enough to draw conclusions about cause and effect. This is a good example for that. So it's basically in this example, this is in the article in New England Journal of Medicine. You can check it out if you want to. So they were looking at the number of Nobel Prize winners in different countries. So, and then the chocolate consumptions. Okay, look at those connections. So what they saw is that there's a huge correlation between the number of Nobel Prize winners per 10 million population. Okay, so within the chocolate consumption. So this is the correlation, 0.791. So that means that, does that mean that the basic meaning of causation is that by changing X, in other words, change in X, we can bring about the change in Y? That is not correct. If you eat a lot of chocolate, can you increase the number of Nobel Prize winners? The answer is clearly not. Okay, so in other words, that's what it is. So in other words, basically, in this setup, a lurking variable such as possibly the country's wealth. In this example, that influence both X and Y can create a high correlation even though there's no direct connection between X and Y. Okay, so that's what it is. So in other words, when you interpret it, there might be a correlation, but be careful if you try to interpret your answer. You don't want to say that if you increase X, that you can increase Y. It happened to be there in the setup, but there is another third variable behind that is going to control that, which is that lurking variable. Okay? So in other words, if you really want to see the connection between X and Y, you need to do an experiment by keeping control with that lurking variable. Okay, so that's what is that. So there's another example. You might want to check it out if you wanted to. Okay, and this one is a good example too. I will put that one in the class note. Okay, so there's another one. So I will put it into the notes. Anyway, what here, lurking variable may explain the relationship between explanatory variables. Correlation and regression can be misleading if you ignore those variables. Okay, the next one, the high correlation does not imply the causation. Okay, all right, so let me stop here.